Let's divide both by 3. 57 divided by 3 will be 19 pi radians over 6. So we started with the 570. We did the dimensional analysis. We said pi radians equals 180 degrees. 570 pi radians divided by 180. We went ahead and canceled the zeros when we were divided by 10. We said, all right, let's divide by 3, 19 pi radians over 6. Now, most times, we will not actually write the word radians. We'll just assume that if we're talking about the measure of an angle, and there's no units, we assume it's radians. And if we want it to be degrees, we'll put the degree sign. So if there are no units, and we're talking about measuring an angle, we call that radians. If there are degrees, we call it degrees. Any questions here? We'll start with Mitzi, and we'll go to Osnai. Mitzi?
For 570, do you also write the degree?
Yeah, because I think in the problem they gave it to us with a degree sign, right? So that's why we wrote the degree.
No, I mean while you're when you carry the radians all the way through.
Well, so this side degree canceled out.
Okay.
That's why we didn't carry it through. Osnai?
Okay, so on that side, pi radians, so we're always going to have to divide it by 280.
Yeah. Now let's do number 4. Let's do number 4. Negative 4 pi over 3. So I look at this and I'm like, all right, I don't see a degree sign, so this must be in radians. So I said, okay, let's see what's happening here. Well, I know that pi radians equals 180 degrees. Pi radians is the same as 180 degrees. And I'm going to say, okay, well, this is really, if I multiply it, negative 4 pi times 180 degrees divided by 3 times pi radians. Now, we know the pi's go away here. The pi's go away here. It's the same thing. Pi's are going to cancel out. So I'm going to have negative 4 times 180 degrees over 3. Now this word radians, remember, this was actually a radian. Negative 4 pi over 3 was radian. We just didn't write it. We're a little bit lazy. So let's just go ahead and cancel this out, because really this was a radian up here. We just didn't write it. So I'm going to go ahead and cancel this word radian with the imaginary radian that was written here. And there was an imaginary radian there. We're just a little lazy. We didn't write it. So negative 4 times 180 divided by 3 could also be thought of as, well, negative 4 times 180 is negative 720 divided by 3. And this is just, math, we can all do this. This is going to be negative 240 degrees. Please ensure you are keeping the negative sign and that the answer has a degree symbol. Jeffrey?
How is it possible you have a negative degree?
I will show you on Tuesday. No. I'll show you on Tuesday. Tuesday, a lot will be revealed. Any questions on this? Let's move forward now. Let's switch back over to this board if you don't mind. Yeah. All right. Now this is something. What's coming next? You can rely. Are we on? You can rely on Miss Fain or Dawson. Have you met Dawson last year?
No.
Oh, okay, so Fain or Dawson. SOHCAHTOA. This we know. SOHCAHTOA. So the S is for sine, and this is saying sine is opposite over hypotenuse. The C is a cosine, adjacent over hypotenuse. And T is a tangent opposite over adjacent. Opposite over adjacent. Now, for the next about week and a half, I'm only going to focus on sine and cosine. We'll then come back to tangent a little bit later. Right now, just going to focus on sine and cosine. So if we had a triangle here, let's just draw a little triangle. Let's draw a little triangle here. Let's call this angle theta. And let's call this side x. Call this side. In fact, let me not even use x. Why don't I use this? Why don't I use A, B, and C? Why don't I use A, B, and C? And okay, if somebody said, what is the name of this side? Does anybody remember what we call this side?
Hypotenuse.
Yeah, very good, very good. This is called the hypotenuse. Hypotenuse. There are really two things to remember about the hypotenuse. One is the longest side, as David said. Longest side. And the second piece is that the hypotenuse is across or opposite the right angle. I'll use the word opposite, across, same thing. Opposite the right angle. And I'm going to write in parentheses here 90 degrees just to remind everybody that a right angle would mean a 90 degree angle. Okay. You may have learned that there was some rule that said this. Do some people remember this? Right.
Oh, yeah.
The Pythagorean theorem, right? Okay. You know, that's not going to be super important yet, but that will become important, so I just wanted to remind everybody. This is the Pythagorean theorem. It says side A, whatever it is, maybe it's 3, maybe it's 20, maybe it's 1,000,000, squared plus side B, maybe it's 10, maybe it's 1, maybe it's 8, squared equals this side squared. This is named after the mathematician Pythagoras. But where we really want to get to is, what if we ask this question? What if we say, what is the sine of angle theta? What is the sine of angle theta? Well, sine means opposite over hypotenuse. So I'm going to just start by saying, well, sine is opposite over hypotenuse. And I'm going to say opposite. I don't really know what that means yet. I'll get there. But I know what hypotenuse means. We already talked about that. So I'm going to write C down here.
B is.
Yeah, go ahead, Barca.
Isn't the opposite what's across from that theta?
Right, so the opposite says this is opposite or across from the theta. It's like sine of theta. So this will be side A. So the sine of theta would be A divided by C. A divided by C. And of course, I could say cosine of theta. And some of you are probably off to the races already. And here's what we get. Right? Cosine of theta is B over C. Hypotenuse is always C in this case. And adjacent means what is next to. Remember, my room is adjacent to Mr. Kurtz's room, next to. So this side is next to the angle. Umberto?
I don't get that one.
The sine or cosine?
The adjacent one.
So adjacent just means next to the angle. So there are two sides that are next to it, here and here. This is already hypotenuse, so that's gone. So we call this the adjacent side, because it is next to the angle. Okay. All right. And now this is where we're going to make our money for the next, 8 weeks. If you know this, what I'm about to do, the unit circle will be like this. You all might recall this.
Oh, the 45, 45.
Mm-hmm.
Yeah. 30, 60, 90.
Let's start with a 45, 45, 90. We'll get to 30, 60, 90 in a second. Now, you all might remember, all this really means is some sort of right triangle. Let's draw it something like this with a right angle here. We call this angle 45 degrees. We call this 45 degrees.
Perfect right triangle.
Carla? Yeah, of course. 45, 45, 90. And what we want people to remember is this. This is what we want you to remember. Root 2 and 2. That's all I want you to remember. I want you to remember that this side is 2, the hypotenuse is 2, and I want you to remember this is root 2 and this is root 2. That's all I want you to remember. That's it. You can write the x, you don't have to. In this case, it's not going to be helpful to write the x. This is all I need people to remember. These sides are equal because this is an isosceles triangle, which means two sides are equal. Root 2 is obviously smaller than 2, so 2 must go on the hypotenuse, the biggest side. I just need people to remember this. And if you get this, then this is what's going to be really helpful for the class. Because if you remember this, then it is just a little division work to get this. Just a little bit of division work. We'll say, well, imagine I have a little bit smaller triangle. Instead of having one that has a hypotenuse of 2, let me just make the hypotenuse 1. Let me draw it a little smaller. So how did I get here? I said, well, let me divide the 2 by 2 to get 1. So I'm going to say, let me divide this to get root 2 divided by 2, root 2 divided by 2. This is money in the bank. This is money in the bank for the unit circle. Teaching it this way, we did not do this last year. This is a much easier way to teach it. So all I did is I said, let me just divide every side by 2. So this becomes root 2 over 2. This becomes root 2 over 2. And this becomes 1. 2 divided by 2 is 1. All right. And now let's draw the one other special right triangle. So I need you to memorize this. I need you to memorize that pi radians equal 180 degrees. I need you to memorize one more thing. 30, 60, 90. Let me draw that here. Man, can't draw this triangle. Thank you. All right, 30, 60, 90. It's important where you place these. The 30-degree angle must be across from the smallest side. Smallest angle across from smallest side. All right, now, this side, and now I need you to remember 3 things. 1, smallest side is 1. Biggest side is 2, and the side in the middle is square root of 3. Square root of 3 is about 1.8. That is smaller than 2, so it must go in the middle. Yep, I need the smallest side to be 1. I need the biggest side to be 2. I need the middle side to be square root of 3. 1, 2, radical 3. Say it to yourself a million times. 1, 2, radical 3, and that's how you're going to learn this. Luis.
Can you give us an example but with bigger numbers?
Yeah. I mean, you could make this 10, 10 root 3, and 20.
Oh.
Now, but again, it's not helpful for this class to have this as a 2. It is more helpful for this to be a 1. So, let's divide every side by 2. So, I'm going to draw it I'll try to draw it a little smaller. I'm not sure I really accomplished it, but. So this is now 1. 1 divided by 2 is 1/2. Root 3 divided by 2 is just root 3 over 2. I need you to memorize this one for me. It might be easier to memorize this and then just be like, oh, let me divide by 2. That's probably easier. 1, 2, radical 3. Root 2, 2. 1, 2, radical 3, root 2, 2. That's all you got to know. You can know that much. The unit circle is like this. It'll be so easy to do. Now, let's try a couple things real quick here before we get out of here. Try to solve these out using the triangles that are boxed. Try to solve this. And just jump in on your own. I'm going to work through them too. Let's jump in with these four. Let's jump in. Try to solve these four. If you can try to do one on your own, let's try sine 45 degrees on our own. Use the definition of Barca. You already have it? No.
Which 45 degree?
Oh, it's going to be the same. You can pick either one. You can pick either one, yeah. Sine 45 degrees. So I'll write on the board what I'm doing. Sine, right, opposite over hypotenuse. Here's a 45 degrees. Opposite side is this one, root 2 over 2. Hypotenuse is 1. We don't need a calculator, folks. We do not need the calculator. I do not want a decimal. I want it as a fraction. And therefore, our answer is this. Sine 45 degrees right here. Some people may have gotten this on their own. Now try cosine of 45. And then keep working your way down. We want to get all these. And if you have a question. Yes, ma'am. Jaylee? Because anything divided by 1 is itself? Does that work, Jaylee? You see the beauty why it's so nice to have 1 as hypotenuse. Because it just goes away. Anything divided by 1 is itself. That's why we wanted the 1s here. Okay, I'm doing cosine now. Adjacent side, that's here. Hypotenuse is there. Does anybody get this for cosine 45 degrees? Does anybody get what I got? Great, let's keep going. Try sine 60 on your own. I'll model on the board. Okay. Okay. If you need to check with me, great. If you're good on your own, just check the answer at the end. And now you can finish it up. And if you're done with that, then move to 30 degrees.
Is this coincidence or is this?
One more time for me.
Is it coincidence or is it just?
No, it is the same, and we'll see again. Tuesday's going to be the big reveal day.
So we don't have to do the divided by 1.
I mean, yeah, so it's really just divided by 1, but doesn't affect the answer. That's why we made these sides 1. That's why it's so nice.
I don't understand.
Where's the confusion, Jose?
I just look at
Those who are good, 30 degrees now on your own.
Why do I have to look at the one that you divided to turn that into 1? Isn't it like still the
So
same?
you just look at root 3. Yeah, it doesn't matter. Any triangle will be same.
So I don't have to do that.
No, this will be helpful for Tuesday.
Oh, it's helpful.
Yeah.
So it's just like a script.
It will make Tuesday's life a lot easier.
Okay.
All right, and finally, 30 degrees, right? We can do that upstairs. Remember, cosine of 30. Here's the adjacent side for 30. Make sure you understand. This is adjacent for 30. So root 3 over 2 over 1. Remember, the over 1 does nothing. Sine 60 degrees. Remember, for sine 30, excuse me. Remember, for 30 degrees, this is the opposite. This is hypotenuse. 1/2 divided by 1 is 1/2. If you understand this and this, the unit circle will be so much easier than last year. I'm so sorry I didn't teach it like this last year. Jenny. Yep, always. All right, start off.